Excellencies, ladies and gentlemen, it's a great honor for me, on behalf of the Organisation pour la mise en valeur du fleuve Sénégal, OMVS, to introduce this session dedicated to using science to inform policy decision making for the sustainable development of the Senegal River Basin. This basin, shared by 4 sister countries, Guinea, Mali, Mauritania, and Senegal, is a vital resource for more than 20 million people. It supports agriculture, fisheries, hydropower generation, water supply, and the preservation of ecosystems. Yet, it also faces significant challenges: climate variability, increasing water scarcity, environmental degradation, and growing demographic pressure. In response to these challenges, OMVS has already relied on science, knowledge, and data to guide its policies and plan basin-wide development. Today, with the emergence of digital tools and innovative approaches, a new era is opening up for integrated and predictive water resource management. In this context, we are pleased to see, with the support of our scientific and technical partners, the development of the Senegal River Basin Digital Twin Project. This virtual model, a true dynamic replica of the basin's hydrological system, will make it possible to simulate different management scenarios, assess policy impacts, and strengthen resilience to climate-related risks. I would like here to thank our partners, scientists, donors, technical institutions, and local actors whose collaboration helps make the Senegal River Basin an African laboratory for innovation and shared governance. I wish you fruitful and inspiring discussion in the service of better integrating science into public policy for the benefit of our population and future generation. To discuss these various aspects, we are honored to have with us today a high-level panel moderated by Mr. Nyokhor Ndour, General Secretary of OMVS. And now, to start this session, we'll give the floor to His Excellency Mohamed Abdel Fattah, High Commissioner of OMVS, to deliver his keynote speech. Mr. High Commissioner, you have the floor.
Thank you, Fawzi. I don't know if you hear me good, Fawzi?
Yes, you can hear you. It's okay.
Thank you, dear colleagues, dear partners, dear friends. It's truly an honor to deliver these opening remarks for our session today, dedicated to the digital twin of the Senegal River Basin. At this important conference, a moment when the world comes together to reflect, to learn, and to act for our shared climate future. Many thanks to all our partners, to the panelists, to Professor Phoebe, to Marieke, to Ketam, to Mr. Director Kwasi, and of course, Massamba. Thank you all for joining us today. In 1972, Mali, Mauritania, and Senegal made a bold and visionary choice to manage the Senegal River as a shared resource, as a common good. Guinea joined us in this commitment in 2006. Together, we created the Senegal River Basin Organization, the OMVS. Since then, we have built dams and shared infrastructure that benefit all of our countries, regardless of where the investment is located. This cooperation delivers hydropower, water supply, irrigation, and beyond that, peace and hope for the future. This cooperation is recognized as one of the world's most successful examples of transboundary water governance. So how did we achieve all this? 5 key factors stand out. First, strong political support from our states. A solid legal and institutional framework. Third, a clear rule. We share both the cost and the benefits. And the active involvement of our local communities. And last but most important, shared infrastructure that serves everyone. This success is real, but it's also fragile. And we are living in a moment of rapid change, climate pressures, demographic growth, and rising expectations, especially from our youth, who are watching closely to see if our generation will give them the tools and opportunities they deserve. In such a context, we cannot rely only on fragmented information. We need science. We need clarity. We need tools that allow us not only to understand today, but to anticipate tomorrow. This is where the digital twin comes in. This living dynamic representation for the river and its systems. It will allow us to test water management scenarios before applying them to real life. It will allow us to anticipate, to optimize energy generation, navigation, support agriculture, and protect ecosystem while balancing needs across countries, regions. In simple terms, it will help us make better decisions together. But of course, technology alone is not enough. For a digital twin to have meaning, it must serve people, it must listen to the river, and it must be rooted in governance, dialogue, and trust. And at OMVS, this is our philosophy since 43 years. For 43 years, our countries have made the Senegal River jointly with equality, transparency, and shared benefits. And we have a vision for the future. Our vision 2050 is here and is adopted by our countries. Today, the digital twin does not replace the actual tradition of OMVS. It will strengthen it. And it is, in my opinion, the next chapter in the story of cooperation. That is why this session is important. We are here to exchange knowledge, to learn from the science, to build new partnership, and to ensure that innovations remains inclusive, involving governments, researchers, local communities, and the young innovators of our basin. The future we want is one where development serves people and protects nature, a future that gives our youth opportunities and the power to shape their own tomorrow. So I invite us today to speak frankly, to share openly, and to commit to solutions that make a real difference for the people who live with and from the river. Thank you for being here. Thank you for believing in cooperation, and thank you for believing in science that serves life. Thank you.
Hello. Thank you, High Commissioner, for your speech. And now we go to the panel. We have a high panelist. We have Professor Phoebe, Mr. Masamba, and Director Ketan, Director Mariake, and Director Kwasi. Now I start with Mariake. Why is science anticipation important for the river Senegal Basin, and why are novel governance mechanisms like, for instance, clinical trial for ecosystem essential for people and nature in the river Senegal Basin?
Thank you. Thank you very much for the invitation. Thank you to our partners of the UNFCCC and to our friends of the Organisation pour la valorisation de la rivière Sénégal, du fleuve Sénégal. Peut-être pour répondre à votre question, je vais commencer par donner un petit peu de contexte sur l'organisation à laquelle j'appartiens, qui s'appelle GESDA, le Geneva Science and Diplomacy Anticipator. C'est une fondation qui a été créée par le gouvernement suisse en 2019 avec pour but, en fait, de faire des ponts. Oh, should I? Oh, sorry. Yeah, sorry. We were speaking in French before, so now I'm all confused, and I looked at your puzzled faces, and I thought something goes wrong. Okay, sorry. So just to give a bit of context to this discussion, I would like to just explain a bit about the organization I work for. I'm Director Impact at GESDA, the Geneva Science and Diplomacy Anticipator. It's a foundation that was created by the Swiss government in 2019 with the objective to bridge science and diplomacy, as the name says, but based on anticipating future scientific breakthrough. So the Swiss government felt that we need to propose new ways or new models of international cooperation based on science before even that the technologies hit society. So what JESDA does in the first place is we work with 2,000 scientists across the world to anticipate future scientific breakthrough, future science, and the technologies that will stem from this scientific breakthrough. And with diplomats, with the scientists themselves, with the local communities, we try and identify how this will help us address our most pressing challenges. So it's about science anticipation. It's about finding, inventing new models of diplomacy and governance. And in this framework, we have a partnership with the UNFCCC Climate Innovation Hub. We're very proud of that, so that we can reconciliate the future possible solutions that will be allowed by future science with the demand that we see now, but the demand that we anticipate in specific regions across the world. So in this context, we have started a fruitful discussion and hopefully very soon a collaboration, field collaboration with the Organisation pour la mise en valeur du fleuve Sénégal. So I would like to thank you, the High Commissioner, and thank you, Secretary General, for this fruitful collaboration already. So the river Senegal Basin for us, of course, is an extremely interesting place to enforce science anticipation. First, because it's a model of international collaboration that works with 4 countries, 20 million inhabitants in this area. And that gives us a strong basis to innovate with pilot projects. Because here it's about how to leverage future science. So but it's not, as the High Commissioner said, just about science. It's mostly about co-constructing with local communities opportunities for development and opportunities to address future challenges and global issues. So there we have a trusted environment to start this collaboration. Now, talking more specifically about the scientific issues and the scientific breakthrough that are anticipated in the JESDA Science Radar, which is online. So I encourage you to go and check this platform. It's an open source platform where we map future scientific breakthrough across 5 key domains and 40 scientific disciplines. One of the 5 key domains is eco-regeneration and geoengineering, so at the core of what we are talking about today. So River Senegal Basin will be affected by, like all of us, by climate change with water stress and climate vulnerability, but also hydrological extremes. And we also identified as an important issue the agricultural needs for more productivity whilst ensuring food security. So at the moment, where we are envisaging the collaboration with OMVS, where what we're talking about is to work together on creating an R&D cell, R&D research and development infrastructure for OMVS to address those challenges, but also for OMVS to equip itself with state-of-the-art infrastructure, digital twin, so that, because we know that the existing water management systems do not suffice. They're based on historical data, so they're actually not that good at anticipating future conditions. So here science can help. So with the science that we have identified in the JESDA Science Breakthrough Radar, we can create integrated hydrological models. We can also use those in this infrastructure to create climate adaptive storage strategies. We can also think about, of course, innovative agricultural practices. So all of this needs to be integrated. There's a lot of science that need to come together in this trusted environment, and that's where anticipation is key. It's not just about creating an infrastructure that is leveraging the science of today, but we have to make sure that this infrastructure is future ready so that it can accommodate future scientific breakthroughs and technology. So that's what we have started doing with the OMVS, and we are very proud of this collaboration. And again, thank you very much for the invitation.
Thank you, Maria K, for your guideline. I think we hope to continue to collaborate with this project demonstration. Thank you. Now I return in an outline. Professor Phoebe, what are the key technical challenges in developing and implementing digital twin model for complex ecosystem like the Senegal River Basin, and how can this challenge be addressed? Professor,
thank you very
Phoebe,
much. Thank you very much. Thank you for having us involved in the projects. His Excellency, the Commissioner, the lead of the UNFCCC Global Climate Hub, Matsaba Thioni. We are all very honored to be given the opportunity to contribute to this very complex but also very important project. It is important because of the sheer number of the people, 20 million, because it brings together 4 countries, that used to fight for these common watersheds, and now they are given the huge opportunity but also challenge of organizing themselves in a collaborative mode, not only to bring peace between them, but also efficiently manage over time and space this most precious resource in order to sustain the well-being of their own generation, but also the generations to come. So this is a flagship project for us. We worked on similar projects before. We worked in the Zambezi River Basin, we worked in Omo River Basin, bringing together a big number of countries owning and needing to manage in collaboration a common resource like this. And it's and we have to work. When I say we, I mean the Alliance of Excellence for Research and Innovation on Sustainability, 200 researchers working in 120 countries across the globe, as well as the Global Climate Hub, the UN Sustainable Development Solutions Network Global Climate Hub, that brings a systems approach to developing detailed, dynamic and spatial pathways of solutions, integrated solutions between technology, policies, and fiscal and financial solutions that can drive the transformational change that is needed in different scales in order to achieve the SDGs. Obviously, it's a big challenge, and let me just number the challenges. The first challenge is that we have systems complexity. So in order to manage these watersheds, we need to understand and model and solve in an integrated manner multiple systems, the climate systems, the hydrology, the geology, And then on top, the biodiversity, the ecosystems and the services they provide. And then on top of the natural resource layer, we have to include the actual sectors of the economy, the agriculture sector, the energy sector, agriculture in terms of both crops and livestock, the different sources of energy, the networks that are needed to support the energy production and provision and distribution. In addition to this, we need to think about transport systems. We also need to think about health systems. We also need to embed the transformative changes of these systems into a socioeconomic system that answers two questions. How do we finance the transformational change, the needed investments, both in infrastructure, but also in capacity of implementing the systems science solutions? And then how do we care for the vulnerable? How we make sure that the solutions that we are proposing and recommending for implementation are going to be equitable? How are we going to make sure that everybody is on board in this transition? So the first issue is systems complexity. The second issue that is again related to system complexity is that we have to build a living dynamic model of one of West Africa's more complex ecosystems, which must be done in a science-based approach. There is a lot of science already on the ground. There is a lot of modeling and a lot of engineering, a lot of data, but we need to improve on that even more. The second challenge, in addition to the different systems that need to be integrated in a consistent and optimal way, is of course data, technical challenges of managing data, collecting data, managing data, and making data interoperable. So in order to put together a digital twin, you must consume data of different types of formats. You need data from different sectors: hydrology, agriculture, energy, economy, socio-economy. And often this data is scattered across different institutions and countries that are incomplete, inconsistent, non-interoperable, and they have serious limits in terms of their accuracy and usefulness for digital twin simulations. So for the digital twin to work, it needs a unified, reliable, and continuously updated information base. In technical terms, this means that it needs the establishment of a basin-wide data sharing protocols, real-time monitoring networks, and data collection through ground observation. So this is the second challenge. First challenge, systems complexity. Second challenge, data handling. And third challenge is, of course, uncertainty. We are in a period of multi-crisis. Uncertainty and vulnerability is increasing. We have climate vulnerability, we have increasing droughts, increasing floods, increasing land degradation, and moreover, we have a financial vulnerability and financial uncertainty and even ambiguity. So we need to alter system behavior faster than we used to do before, than the traditional models can adapt. So this is another challenge, the increasing uncertainty. And because we want our solutions, our suggested solutions, to be sensible in the short, medium, and long run, and of course we know that time and uncertainty have a positive correlation. The further you move into time, the higher the uncertainty, the higher the ambiguity. Uncertainty is when you know the probabilities of different events. Ambiguity is that you don't even know those probabilities. So you have to build a system over time and space in a way that is adaptable and flexible enough to handle all this uncertainty and ambiguity. And fourth challenge, finally, is of course co-designing this digital twin, not on a technical basis only. Science has to speak with all the people there. The people, the stakeholders, the highly skilled people that are managing these systems, but also all other stakeholders that may not have at this point in time the capacity to be true participators in this co-design approach, to be supported, to be upskilled, to be included in the conversations, to be included in the living labs where we gather all the stakeholders and present the science-based solutions. And then on these presentations, we co-design and co-adapt our understanding of the river basin, our understanding of the natural system, the socioeconomic system, the technical capacity, the technical problems. And at the end of the day, we directly speak to each other and co-design something for which co-design a digital twin, which is the product of the wisdom of science, practitioners, general public, the old and the young, those who have resources and those who don't have, in a way that we reach our goals in an equitable and social welfare supporting way. So 4 challenges, all solvable, but really big ones. Thank you.
Thank you, Professor, for this magistral course. I think you have many challenges and we are the solution also. Thank you. But now I go to Masamba, Dr. Masamba. Why eco-augmentation demonstrations are important, and how would you advise to integrate digital twin technology into existing policy and decision-making frameworks? What changes are needed to effectively utilize these tools? Masamba, the floor, you have the floor.
Thank you. No, thank you. Thank you, Nyohore, and good morning, good afternoon to all of you. Very pleased to have this opportunity to contribute online. The future that we need is a co-flourishing future, which is a future whereby human and non-human living can radically collaborate and mutually enhancing one another's capability to thrive. It's not about human dominating nature to satisfy their need, but it's about human collaborating with nature. In particular, the core human needs should be satisfied for the many people, no one being left behind, while increasing the well-being of the planet, or at least keeping human activities within the planetary boundaries. Our current society cannot build that future because it satisfies the core human needs following a model locked in fossil fuel, linear, and extractive. Indeed, its economy is optimized in terms of effectiveness and efficiency within that same model, the fossil-based, linear, and extractive model. There is an infrastructure locking with trillions of US dollars invested in assets generating negative externalities such as urban layout, power plant, and industrial processes. And there is also a skill locking with most of the workers having built a competence that will be obsolete in a green transition future. So such transition will therefore can therefore result in stranded people. And finally, there is a behavioral and institutional inertia that support the status quo. So government cannot and should not develop and implement policies that would result in stranded asset with the risk of financial failure, as well as stranded people with the risk of social crises. And this is where it is really important to focus on the first point that I would like to make. Policy alone cannot break the locks, because as I have said, no government will put in place policies that will lead to stranded asset and stranded people. So this situation entails innovation to develop and deploy at scale alternative products and services that generate positive externalities, are more effective, more efficient, culturally accepted, accessible, and scalable. And these new products and services should be able to accommodate the repurposing of the assets and skills that they are disrupting, so that we can avoid stranded asset and stranded people. The key message is this is nothing less than reinventing the world. Human alone cannot do it. Radical collaboration between human and non-human living that mutually enhance each other's capability to contribute to addressing the global challenge is needed. That necessitates reinventing ourselves. And my third key message, the driver of the co-flourishing transition, whereby the core human needs would be satisfied for the many people while increasing the well-being of the planet, will be an integrated approach to innovation, combining technology innovation with eco-augmentation innovation, innovative policies, innovative financial instruments, innovative business model, innovative cooperative approach, and innovative product from the culture and creative industry to facilitate adoption. Now, we define eco-augmentation innovation as any innovation that combines scientific understanding, ecological principle, including endogenous knowledge and adaptive design, bioengineering, and biotechnology to deliberately enhance the performance, resilience, and co-flourishing capability of ecosystem, including in areas dominated by humans such as cities. So eco-augmented innovation to build an eco-augmented society is the key instrument for building the co-flourishing future we need. A future that is productive rather than extractive, of ecological value, regenerative rather than destructive of ecosystem, and empowering rather than alienating of consumer. Now, on how to integrate digital twin technology into policies very quickly, the basin digital twin is a live multi-layered model which integrates hydrology, infrastructure, land use, climate, socioeconomic use to continuously ingest observation, satellite, IoT, and run scenario simulation to support operational decision and planning, as well as stakeholder engagement. It can increase timely situational awareness, enable testing of policy options before field action, and improve coordination among the 4 states that share the river. One thing that is really important to highlight is that this digital twin can be used to do a lot of things. First, it can be used to paint a future that we would like to build, backcast from that future, and translate that future into concrete action to implement to get there. It can be also used to respond to the question, what if? Where instead of having this backcasting scenario, we have a forecasting scenario that will inform about what will happen if action A, B, and C are undertaken. It is also a means to facilitate participation of the stakeholders that can actually get information from the digital twin, but that can also provide input to the digital twin. Now, the change that will be needed, the Senegal River Basin will need new decision pathway that gives analytical output for more weight in operation and transboundary coordination. We will need a unified data and standard with open data architecture, metadata standard, interoperability, and clear data sharing agreement across countries. We will need internal technical team and collaboration with institutions such as the UNSDS and Global Climate Hub for modeling, data science, maintenance, plus user training and policymakers. Finally, we need also finance and partnership. Blended funding will be needed where probably we'll bring on board the MDBs, donor, public financing, private financing also, and stakeholder and equity design will be also needed. I will stop there and yeah, back to you.
Thank you. Very relevant. Thank you, Masamba. Now I come to the room, Mr. Alexis, Director in Water Resource in ECOWAS. What tools and partnership does ECOWAS offer to the innovation in transboundary basin?
Thank you, Mr. Secretary General. I think I can thank everyone for this opportunity we gave to ECOWAS. ECOWAS is the economic community for West African states. So it's an intergovernmental organization for the West African working in various sectors as well water resource management sector. So I'm leading the Water Resource Management Center for the West African. So as coming to your question, I think the opportunity we give to this organization or this center to have a partnership with scientist community in the West Africa and around Africa and also the world to give knowledge and science researchers opportunity to develop some knowledge in the river basin in West African country. You know, in West Africa, there is each countries in West Africa shares a river basin in the communities, in the local communities. So it's important for us to have this kind of collaboration with the scientists in making decision and for making policies for the West African countries. So we collaborate with West African scientists in the universities. You know, in West Africa, the universities has like an excellency centers for the development of research. So we collaborate with them. And also we collaborate with the River Basin Organization for the West Africa. In West Africa, we have 5 River Basin organizations. So it's good to have this network of River Basin Organization and to work with the scientists to develop policy. We did it for the West African water resource policy since 2008. And actually we are updating this policy, and the scientists are parts of the development of this policy for the new vision of water resources for the West African people. So this is some kind of collaboration we have. And also we have a collaboration with the West African the Organization for Sahel and Sahara Desert. It's an observatory is an organization, observatory organization based in Tunis. So we work where there are scientists, searchers. So we work with them. We work also with WASCAL. WASCAL is a West African scientist organization. So we work also with them to develop tools and to develop technologies for the management of water resource in all West Africa, but also in river basin organization like OMVS. And we continue. I think we are very happy to have this collaboration, and we can continue. It's important to have this kind of collaboration between decision makers, policy makers, and scientists in order to have a very strong policy for the community, a local community. But the very important things is also for the scientists to have a collaboration with a local community around the rivers basin to have a strong information and data to help decision making for the West African people. This is what I can say at this stage. Thank you.
Thank you, Director. For Warren Flores, I think it is online. How can digital twin model incorporate local knowledge and community input to ensure that policies are inclusive and sustainable?
Well, thank you so much for the invitation, and it's really honored to be among all of you, and really great intervention so far. So I will try to tie it in together in this space. I think all of my colleagues have touched on the point that we need data, and not just any data. We need a quality and integrity data, and I think we all agree on that. Digital twins runs on data, and runs primarily in data provenance, knowing where the data came from, and knowing where we can verify the data. It's not just the GPS location, but there's actually the data that's interpreted. Who interprets the data? What kind of knowledge are we arriving from that data? So one of the things that, if we want to bring indigenous knowledge, and in this is where we kind of probably depart from some of my colleagues, is that we need to start looking indigenous knowledge as indigenous science, technology, and social structures. They have a very particular way to organize society, and very particular way of doing science. Science that is embedded within their practice. So one of the things that we work at Kinroy Hub and also as part of the eco-augmentation group is indigenous data standards. Masamba touched in this, mentioning that we need standards to exchange data across ecosystems. But this is not just about nation states. We need to have data standards to flow between communities, scientists, and the digital twin offices that maintain the flow of the information. In indigenous data standards, then we start thinking about data conceptualization, data collection, data aggregation, and data disaggregation. So far, when we try to include indigenous knowledge into these ecosystems or local governance structures, we are really called by the multiple interpretations that we might have to what is indigenous knowledge and what is the social organizations of these local communities. We need to find ways to standardize such that we know what data are we bringing into the digital twin. Otherwise, we are really flowing back and forth on interpretations. And sometimes we are cherry picking indigenous knowledge to bring into these digital twins and information. And the second piece is that more and more we are seeing really the emergence of the rights of nature. And who are very good at understanding what is at the central level of rights of nature are the local communities. Local communities that are living within the ecosystem that we are trying to protect, and we need the resources to keep momentum in sustaining life. So really the data that we're talking here is really going back and thinking about indigenous data sovereignty in this context, to give people in the ground back that data for governance of their ecosystems. And I believe that digital twins can do this by interpreting the data that's coming from provenance and maintaining indigenous data standards in the collection, conception, aggregation, and disaggregation. We can actually return the policies that actually responds to the needs and the agenda of the local communities. And this could look in many ways. One of them, it really looks down into transboundary water management and soil health management. If we are in really that trying to build the agriculture sector and the food systems. So far, we haven't done this a very good job to bringing indigenous knowledge as a complementary to other sciences. And the digital twin can help us to do this in a better synchronized way. They can flow back and forth the information. Some of the things that we are trying to do, really, if I were to put an example in this, is we are trying to utilize the digital ecosystems to really bring more data that we need to make better climate predictions. But to do this, I think some of my colleagues already touched, to do this, we are far away from where we believe we are. We have corporations and communities that they want to do, but we are still lacking a significant digital public infrastructure to make this a reality. So we might be start thinking about what are the needs that we need to accomplish now before we start focusing so much into building the digital twins or building the digital ecosystem by itself. In some of countries, rather than it doesn't have accessibility into the ground. So we are seeing in Latin America, where are more focused on most of my experience will come in, we don't have digital public infrastructures that are accessible and available for our communities to participate in the data collection. So the data is very siloed, it's very breakdown. And most of our models in climate change, they are really in the global north, in the minority worlds where they have the towers to collect the data. So from the ground, we're seeing a very little data provenance that's coming in to match what we need. So we need three things that I believe that we need in order to bring indigenous knowledge into the digital twin, from the digital twin, bring forward policies that answer needs and priorities and the agenda of development in the ground. We need indigenous data standards to flow from communities to digital twins, to policy, and back to the communities. We need an indigenous data sovereignty framework in all agreements. We are losing data, really, not to the public sector, but actually we're losing data to the private sector. We are losing data. Think about ecosystem genomics. Our food systems is being patented, is being lost, our food sovereignty. And all of that is not in the public infrastructure, it is actually in the private infrastructure. So we really need indigenous data sovereignty to help us flow back some of the data economy that will fuel this. And then, of course, we need this to start looking indigenous knowledge, not as a patch to the mantra or systems change, but we need to start seeing indigenous knowledge as a complementary to other sciences that brings ground truth into the data that we are collecting at the larger ecosystem scale, all the way from satellite data to towers and carbon fluxes that is mostly located in the global north. That ground truth data will help us really to drive policies that creates actions afterwards. Otherwise, we are seeing a lot of policies and agreements that are at best in skewed data that is looking more so at the bigger picture, but not at a regional level. If we do all those three things, I think we can actually emancipate ourselves from the doctrine of discovery that has driven us all this way into this point. This is as much as I can say in bringing indigenous knowledge into the digital twin and flowing back to the internal agenda and priorities of the communities on the ground. Thank you.
Thank you, Flores. Thank you. Data collection and data is very, very important, and to include community is also important. Thank you. Now, we need the guidance of Director Ketan. We say many things, and I think we need to realize, and we need investment. And for Ketan, what are the key investment area and support mechanism necessary to scale up digital twin technology for basin management in West Africa?
Thank you. Thank you very much for inviting me and for hosting this very challenging and interesting session. I've listened very carefully to what was said, learned so much. I will try and add something that is different rather than repeating so many of the many good points that have been said. Thank you also to Masamba and to Phoebe for inviting me here. I mean, firstly, I would of course agree that this is one of the critical transboundary system projects, which, if successful, has far-reaching effects in the region itself, but sets an example for many other parts of the world with these challenges. And it's a peace project as much as an economic or a project. So, you know, that really matters. And I echo what Phoebe said earlier on that. Leveraging digital twin technologies and eco-augmentation finance can transform the basin from a subsidy water economy to a data-enabled market system, ecosystem. And that would drive regional resilience and growth. But today, the economic base, of course, is underdeveloped relative to its natural potential. So then the real question is, how do you tread that path, as Chair, as you asked, in terms of the key things required? And this is not easy because the circumstances of the basin and its countries is so specific. And it is very difficult to find examples that have been successful, wildly successful, with this population size, these challenges, and this economy. So we found ourselves looking backwards to see where was it like that somewhere else in the world that provided the examples and the lessons. Most of the examples are too large scale. So, for example, China, the Yangtze River Basin is a fantastic example of an eco-cultural system that has been developed that now has hydropower, shipping, manufacturing, and so on. But it's too big. You know, it's nearly 500 million people. China has a smaller basin in Yongding River Basin that is slightly more comparable, but it's 20 million people. But it has developed very successfully, ecological and cultural economy. It's mid-scale urban agricultural basin now, and it is successful. And there are many good lessons there for 20 million people. In Europe, in Italy, you have the Po Basin, which is nearly 40% of Italy's GDP is captured there. It's an industrial agricultural economy and an advanced infrastructure base as well, 17 million people. We ended up thinking the most interesting example potentially was Vietnam. If you go back to look at the Mekong River Basin, you find that its GDP per capita was low in 2003. It had a takeoff based on a series of economic measures that created a really vibrant community, attracted foreign capital, lots of private capital. That combined with public infrastructure and policy allowed for something to really flourish around the basin itself. But it is 17 million people, and it is 3 to 5 times the economic size of the Senegal River Basin in terms of GDP per capita and also population. So our challenges are really specific, but we ended up thinking Vietnam had actually shown part of the way. Now, that's not to say that the challenges can't be overcome, and we have some heroic efforts, of course, that are happening to do that in this particular project. The strategic imperative changes from the early stage to the late stage. So at this stage, until it is a broad economic ecosystem and a commercial market, we need strategic public good infrastructure. And the financing that goes with that is usually MDBs. But the ambition has to be to build a foundation for future value creation and monetization. And the key investment priorities that have been mentioned, like the data infrastructure, sensors, satellites, cloud systems, so on, that's absolutely true. The governance and capacity, strengthening the OMVS, standardizing data protocols, and then demonstrating execution. As Masamba said, it's about people making change happen. So measurable gains. I think many of you have mentioned this. Measurable gains in irrigation, in hydropower, flood risk management, so on. If these things happen, people start to see the execution, which leads to potential future revenue pathways, which are many. The forecasting and paying of these services, the payment for ecosystem services, carbon, biodiversity credit markets, licensing of this data. But the interest in all these revenue streams is proportionate to the economy that one develops. So the core message really is the digital twin must create a market that evolves from subsidy to self-sustaining value, and it has to be part of a broader ecosystem. And in that regard, what we did see in other parts of the world, taking the lessons of some of the ones I've mentioned, including Vietnam and in China and other places, is number one, there's policy reform. Number two, there's some sort of trade integration. Number three, there are industrial zones. Number four, there is a public-private partnership model for capital and for other resources. There's a development of human capital and the stability of a consistent shared macroeconomic policy and political continuity. So all of these things were requirements, but the skills training, the building of capacity, competence and skills was a cornerstone of all of these, in addition to all the other things that I've just mentioned. And I'll stop there.
Thank you, Director Catton. It's very, very relevant. Désolé, we haven't enough time to continue because it is the time, and I want to congratulate all the panelists. It is very, very, very relevant. We have many propositions, many solutions. We have souligné many challenges, and I think we continue to discuss and to co-construction in French, and I think it is possible to write this project. I don't know, High Commissioner, you are online to make a last word. High Commissioner, I think it is.
Yes, I'm online.
Yes,
just few words of to express our deepest thanks to the panelists, to the contributors, the scientific, the private, the public, and also all the perspective that we heard today. I think we have the most important is the vision and the commitment, the political commitment from our side. And we have around us people with many different skills, and we are sure that with the contribution today and with the commitment that we have and with the vision that we have at the Senegal River Basin, our vision 2050, I like the one Masamba said that it will help us. We take a scenario and to see how we can go there. So of course the challenge will be out there, but we are here. So thank you all for your input today.
Thank you all. Thank you, Assistant. Thank you. Okay,
thank you. All right. Thank you.